this video we're going to take a look at solving some logarithmic equations and just look at a couple examples from our assignment. And we're going to use these properties. We've got the product rule, quotient rule, power rule, and our change of base if we need it here. We want to find exact answers here. So in this problem number 13, we can't get the logarithms all by themselves on each side because this 1 is right there. So what we need to do is we need to use the properties to combine these logarithms first. Before you do any combining, we've got to get the 1/2 out of there. So that's the first thing to deal with. So let's send that up as the power rule, using the power rule, that is. So we have log of x minus log of x plus 4 to the 1/2. Okay, now that whole thing's really inside there, the logarithm. But let's leave it like that, okay? So now let's combine. We've got a subtraction going on here. So that's subtracting logs can be combined using the quotient rule. So we've got log, let's try that again, log of a big old quotient here. We've got an x on top, and we've got x plus 4 to the 1/2. Now that 1/2 is not too pretty, but we'll deal with it in a moment. Now this is log base 10, remember, because it's common log. So now we can use our definition to rewrite here. Our definition of logarithm said that this means 10 to the first, which is 10, is equal to x over x plus 4 times 1/2. Now to get rid of this half, we're going to square it at some point in time. Maybe let's go ahead and multiply both sides by x plus 4 over 1/2. Okay, multiply both sides by that, and we have x equals 10 times x plus 4 to the 1/2. Okay, and so we want to get rid of that exponent there, so let's go ahead and raise this whole side to the second power. We're squaring both sides. So x squared equals, now you got to watch out, we got to square both. This is 100, got to square the 10, and you got to square this x plus 4 to the 1/2. Now x plus 4 to the 1/2 squared, well, this 1/2 squared is just going to be x plus 4 to the first. X plus 4. All right, so distributing, we got x squared equals 100x plus 400. And let's solve this up. Set it equal to 0. It's a quadratic now. Notice the logarithms are all gone. That's handy. That's going to be minus. Let's go back up there. Okay. So minus 400 equals 0. And that's just kind of ugly there, but using the quadratic formula, we can get an answer there. X equals 100 plus or minus square root of 100 squared minus 4ac all over 2a, that whole deal. And when we simplify that, we're going to get 50 plus or minus 10 root 29. Now that's a big ugly number, but we get two decimal approximations here. 103.85 when we add, and 3.85, negative 3.85 when we subtract. Now, we got to check one more thing here. If we take 103.85 and plug it back in here, is that okay? Yes, it is. You can find the logarithm of 103 plus 4. You can find the log of 103, no problem. But if you take this negative here, negative 3.85, and you plug that in here, it doesn't cause a problem here. But over here, we try to find the logarithm of negative 3.85, and you can't do it. So after checking, we've got to throw out this negative logarithm here. So let's throw that out. I'm going to cross that out here, like that. So the negative doesn't work. This negative 1 doesn't work. So we have one answer. There it is there. And that is 50 plus 10 root 29 is our exact answer. So once you get an answer, don't forget to plug it back in to see if it actually is a possible solution. If you get negative numbers, watch out. They can cause problems. All right, another one here. We got a bunch of natural logarithms. So we're going to put these guys together and see what we end up with. We have a sum here, so we can write that as natural log of x minus 3 times x plus 4. So it becomes a sum there. Put this guy up. This is the natural log of 2 to the third. And, oops, lost a parenthesis there. Multiplying this out, we get the natural log of x squared plus x minus 12. And we get a natural log of 8 here. Now these are both natural logs. And so in this case, we can, right now, we don't need to move this over. We just write this as x squared plus x minus 12 equals 8. So basically we're just eliminating the natural logs because their arguments are going to be equal. Okay, so that's gone. Now it's just a quadratic. So x squared plus x, subtract 8 from both sides. Two numbers that add to 1 and multiply to 20. I believe we know those. Those would be 5 and x equals negative 4, or x minus 4. And so we get two answers, x equals negative 5 or 4. Now once again, we got to check these out. We got to go back to the original problem. Take negative 5, put it in here. If you put negative 5 in here, this doesn't work. So negative 5 is not in the domain of this part of the function. So negative 5 has to get thrown out. Don't even need to test in the other one, even though it doesn't work there. 4, positive 4. If you put positive 4 in here, this becomes 1. That's okay. 4 plus 4 is 8. That's good. So we have one solution. It is 4. X equals 4. Don't forget to test them out after you get multiple solutions. And this happens whenever we deal with quadratics. When we deal with quadratics, we're going to have what we call extraneous solutions. Number 15, a very similar problem here. We're going to combine them using our product rule. So we have x minus 2 times x plus 5. And this would be log of 3 squared, very similar. And cleaning this up, well, we notice, first of all, they're both logs. So, and there's nothing extra out front, nothing being added, no constants, nothing like that. So this is just going to be x minus 2 times x plus 5 equals 3 squared. By the way, what we just did, it was kind of sneaky, but what we just did was we just raised each one to the 10 power, and 10 to the log of all of this is just equal to this. 10 to the log of 3 squared is just 3 squared. Okay? So that's really what happened, but in effect, it just kind of crosses out that log because both sides are equivalent. So we get x squared, and what do we got here? Plus 5x minus 5, or minus 2x, so plus 3x, and minus 10 equals 9. Subtract 9 from both sides, x squared plus 3x minus 19 equals 0. And let's solve that up. I don't think we're going to factor that thing. Nothing's going to happen there, so we need the quadratic formula. X equals negative 3 plus or minus 3 squared minus 4 times 1 times negative 19 all over 2. Let's clean it up. Negative 3 plus or minus the square root of 92 all over 2. And 92 happens to be 4 times 23, so we can square root 4 and we get 2. Can't simplify really anything here, so there is our exact answer. However, notice if we do negative 3 minus 2 root 23, that's going to be a negative number. And if you take a negative number and plug it in here, that's going to cause a problem. So we can't use the negative here. If we do the plus, negative 3 plus, well, the square root of 92 is something like 9 point something. And so negative 3 plus the 9 point something is going to be a positive number. And so it's going to be about positive 7 divided by 2. It's going to keep this to be positive. So negative 3, our one and only answer is negative 3 plus 2 root 23 all over 2, which is approximately 3.296. And yes, if you plug 3.296 into here, it keeps it positive. We just got to make sure the numbers inside there are positive, the arguments are positive. All right, there's our one answer. So that's how you solve these problems that end up being quadratic. Always make sure you plug them back in and check.